example number 2, the temperature of a quantity of ideal gas was held constant in an experiment. So again, something's held constant, temperature's held constant, that just means it's not going to come into play here. So all I need to worry about now is P1 equals something, V1 equals something, P2 equals something, and V2 equals something. And my formula, instead of being PV over T, I just need to focus on the P's and the V's. So PV equals PV will be my formula used this time. So again, if anything's held constant, it's irrelevant. And again, sometimes it'll tell us it's held constant at a specific number. It still doesn't matter. The temperature of a quantity of ideal gas is held constant at 800 degrees Kelvin. Fine, it's still held constant, doesn't matter. All right, so if they tell you what it is or they don't tell you what it is, held constant's the key, doesn't matter. The original pressure was 7 atmospheres. And the original volume was 42 liters. So that's the original setup. If the volume were reduced to 10 liters, so reduced to 10 liters, that's the new volume. What is the new pressure? And again, pressure is in atmospheres this time. And as I mentioned earlier when somebody asked, atmospheres is the air pressure on Earth at sea level. So 7 atmospheres is pretty pressure filled. All right, so if my initial stuff goes on the left, my initial numbers are 7 and 42. So 7 atmospheres times 42 liters equals the final pressure we don't know yet times the final volume, 10 liters. And if I just multiply that, I'm going to get 4 carry the 1, 294. Yep. Equals 10 piece of 2. Divide both sides by 10. And we get piece of 2 is going to end up equaling 29.4. I'm fine with decimal answers on these. 29.4 atmospheres.
Can you do the fraction? Can you write it as a proportion?
Well, these are gone, then it's not a proportion anymore.
Okay.
It's just a product of things at that point. So again, since temperature is held constant, the over T's are gone. So you're just left with a product equals a product. So then just do a little algebra at that point. All right, so 29.4 atmospheres. Notice the volume decreased, the pressure increased. Okay, and that's what you should expect to happen to those things. As volume goes up, pressure goes down, and vice versa. And temperature, if temperature increases, pressure or volume will increase in relation to that. So the numbers will work themselves out with the math, but just if you kind of have a feel for what's supposed to happen, you can kind of get a basis for what your answer should look like, see if they seem reasonable.